Welcome everyone to the Power Industry Consortium call. We are here with our guests from the Power platforms to discuss the ways in which the Power testbeds can support the implementation of the National Spectrum Strategy Plan. The National Spectrum Strategy was released at the end of January, in January, and we expect that an implementation plan, it was released at the end of 2023. We expect that an implementation plan will be released in mid-March, and we think that there are ways that the Power platforms can be used to support the data collection, as well as the experimentation that needs to be done to make sure that our nation's spectrum resources are used most efficiently. I want to start by thanking our participants. We have Kobus Van der Merwe from the University of Utah and the PAWR platform, Hongwei Zhang from Iowa State University and AERA, Ismail Guvenc from AERPAW and down in Raleigh, North Carolina, Manu Gosain representing Colosseum at Northeastern, and also Ivan Seskar from Cosmos, who will be joining in where he can while reporting live from an NSF conference nearby. So with that, we'll get started. Please, everyone, hold your questions to the end. We will have a discussion here that will be moderated, and then we will open it up for questions and answers. So to get started, as we've all said, we know that there's a lot of work to be done in implementing the National Spectrum Strategy. And we also know that the NTIA has suggested there are some specific targeted bands that they will start with in terms of studying for use for both commercial and federal use and what the needs are there. So I want to ask the group, what meaningful data could be collected in these bands today? So we're talking about the ones the NTIA has identified are the lower 3 gigahertz, 3.1 to 3.4, a portion of 5030 to 5091 megahertz, so a portion of that band, the lower 7 gigahertz band, and then a couple of higher ones, 18.1 to 18.6 and 37 to 37.6. So throwing it open to the group, what types of data sets should we be thinking about collecting in these bands so we can study them for potential future use and support for the wireless networks that we need to deploy?
Do you want us to just jump in, or
you can jump in
on us?
No, you can jump in, but Kobus, let's start with you.
So we've actually supported a couple of external folks on PAWR to do spectrum measurement kinds of things, and so in some sense that's the framework from which we're thinking about. And some of these were in sub-6 where we have our own equipment, and some were in millimeter wave. And of course we've done our own measurements as well, and we have SDRs and antennas and all these kinds of things. But I think I want to sort of make the point that I think a lot of the folks who might want to do measurements in this space, and again we've seen that with the external folks who've used PAWR for this kind of thing, they have their own equipment, right? So it's not as if they will necessarily want to come in and use ours, although there are cases like that. And so I think this becomes more of a supporting act in some sense, where we provide them space and maybe apply for appropriate spectrum use, or they do it themselves. We've done things like custom mounting points and rooftop space and things like that. So that's sort of the way I think of it. So I think, yeah, just to summarize, we have equipment that can support this kind of stuff, but by and large, I expect people who care about these things will come in with their own sophisticated equipment.
Mari, if I jump in here,
Please,
just to build off of what Kobus is saying, but also just taking a 30,000-foot view as to what is motivating this implementation or a release of a spectrum strategy as we drive towards the next generation of standards. And the bands you identified, I mean, it is pretty clear if you look at the pillar 3 in the strategy plan, they are talking about heavy use of spectrum sharing, coexistence. And for that, I think the platforms are really well suited, again, initially due to the FCC Innovation Zone designation that sort of does lower the barrier of entry for these kinds of experimentation. Majority of the PAWR platforms are also part of the NSF and RDZ program that is looking at this implicit sharing paradigm as we sort of move forward. But I think if you really break it down to what you offer, You're looking at things like IQ-based spectrum sensing. So Kobus alluded to the use of proliferation of SDRs in all of the platforms, including on the Colosseum side as a channel emulation environment. So you have this notion of spectrum sharing, you have this notion of a near real-time spectrum map, and then you have a notion of a real-time spectrum-aware database, and how all those things are made available to the experimenter community or any third-party user that wants to use this. We have an overlaying, management and orchestration framework that makes the measurement of these different data points at the granularity, at the timing and synchronization required possible for the first time. So I'll pause there, pass it to the others.
Yeah, so maybe I can jump in, and I want to second what Kobus was saying, that we are witnessing most of the spectrum monitoring and spectrum usage experiments done by outsiders as sort of they bring their own equipment. And in this particular case, an enormous number of measurements done on millimeter wave stuff in the cosmos. But also to sort of point out, touch on something that Manu mentioned, which is NERDS or NRDZ, where we sort of are now trying to expand our bands to go above 6 gigahertz capabilities of the testbed to sort of cover 6 to 12 as well. And that's pretty much ready. There are some issues with the antennas, as you can imagine. I mean, trying to sort of span from 0 to 12 is not easily doable. And that's the issue that's the technological issue that we have to address, but the electronics is there. So however, as Kobus said, most of the external uses we see are people bringing their own equipment. And then there will be some other questions related to sharing, which will touch on what we do versus what others do. So that's sort of an interesting paradigm that we need to figure out a little bit more.
So Manu mentioned going down to the IQ sample level in terms of data collection. What are some of the challenges, and how are the folks that are looking at some of these, trying to understand the occupancy, the potential interference patterns? What types of data need to be collected and can be collected, and how, what are some of the barriers or some of the challenges to doing that? Not specific to, the environments on the platforms, but just in general in terms of the challenge that we face trying to understand the behavior in these different spectrum bands.
Maybe I can jump in here. I can provide AERPAW's perspective. So what I see is broadly there are 2 different types of data sets that may be possible, and we have been collecting. So one is IQ. I think that's probably the most valuable one. With IQ, you can go all the way down to synchronization and do all the receiver processing, and then can obtain some KPIs like RSRPs and etc. The other one is just spectrum sharing, just the PAWR data. And we have been collecting a lot of those in the 3D space. So I think as AERPAW, the 3D spectrum monitoring and propagation is critical, because for sharing, ideally we need to have spectrum measurements everywhere in 3D space, right? So we don't know where which receiver transmitter are going to share. So, but we have to collect enough samples in the 3D space so that we can interpolate accurately. So if you have spectrum measurements, there are ways to do that. And the third one is, I think, that has the least granularity is KPIs like RSRPs or RSRQs using like Quectel modems, or we have Keysight Nemo, we have an Android app. So you can just fly a mobile phone and collect those data. But then you are just stuck with that data, so you don't have more. So I think IQ gives you the most value, but there are challenges of collecting IQ, like with SDRs. We have been collecting a lot of those data too. So the 2 critical challenges we see is if you try to collect all the IQ samples, your SDR stops dropping samples. So we collect 20 milliseconds at a time, and then we are silent for another 80 milliseconds. So you are losing some information there. The second complication we have seen is we have collected a lot of IQ from our own base stations and towers with the drones. We also collected some data from commercial bands, but then it becomes complicated to share that. So we haven't been sharing that data. We have been sharing our own IQ samples from LT and other sources, but I think sharing becomes complicated because someone may decode them and have some sensitive information potentially.
But the government's going to solve that, right? By overseeing the partnerships that need to happen here between the government and industry. I'm sure that will be the case. It will go very smoothly. So we talked a little bit about how to share that data. Are there formats? Are there ways that will make the analysis of that data? I mean, because I'm thinking about the spectrum implementation plans going to happen. It's going to be, a lot of engineers involved, but there's also going to be a lot of policy folks involved. How should we think about what these data sets will look like and how you can pull analysis from them that's actually going to be valuable to the discussions that the policymakers are going to have? I love getting to ask the questions because I don't have the answers.
So I'm gonna use my answer to go back to what Ismail said, right? So yeah, I think if we think of this from a research perspective, then IQ samples is the thing. But I think it's really horses for courses, as the case may be, right? It's depending on the question that you're interested in would dictate the data that is most useful to you. And then maybe a little bit more to what you were asking specifically, Mari. I think so we've sort of, and I think most other folks focus on SIGMF as a low-level format because it's it's extensible and there are tools associated with it, and specifically it has means to collect metadata, which I think is really crucial for any data set that you collect, because you need to know what the conditions were and where it was, and on and on. So that I think is pretty crucial. And then one more, and this is really just a random thought. I think as you go up the food chain, as it were, in terms of providing input to policymakers, good visualization, right? Because you need to be able to kind of see what's going on, and you need to be able to see what's going on at all these different layers. Yes, you want to see it at the really low level IQ level, but you want to be able to pop up a number of levels and say, well, what's the impact of that? What's the coverage? What's the how far do I see that? Do I care about it over here? Those kinds of things that, and I know we're going to talk about this later, but that ties in with the sort of the spectrum intelligence kind of stuff that Manu talked about, right? So knowing what's going on, but also being able to visualize them.
And Mari, just to add to that, right? Just to maybe quantify it, just with a very small sample, right? So if you are looking at, and just to hammer on the IQ piece, right? If you're looking at a sample of 1,024 IQs in the frequency domain, and you're trying to process them using like today's CPUs, it's about 15 milliseconds. Or if you're using a GPU, you can push it down to 8 milliseconds. The reason I sort of put this out there is because you're going to see sort of this notion of AI, ML, and deep learning that'll be associated with the current environment sensing capabilities. So right now, that's on the order of 240 seconds for CBRS, for example. But now when you're trying to work through these AI, ML pipelines, and you can use techniques like IQ mirroring, et cetera. But then what that allows, and then just to sort of reemphasize Kobus's point of visualization, that now takes it from the classical waterfall spectrum measurement model to something that's a little bit more bespoke to what you're trying to look for. And the last thing I'll add from a policy perspective is I think the power of AI ML will also allow you to have development of customized local spectrum access policies instead of a blanket cover whole of nation kind of an approach, because you can be so targeted and tailored based on the utilization and usage of spectrum. And that's what probably these platforms today can help validate, if that is a notion, and that probably gives the policymakers a little bit of ground truth.
Yeah, I want to go back to that in just, sorry, Ivan, go ahead.
No, I was just going to say, there are actually, when we talk about IQ, there are two issues. If you go to higher frequencies, the bandwidths are much, much higher. And then we start talking about the data size and where do you store it. And then a second thing that I think Ismail touched on, we are seeing reluctance of our experimenters to share their data because if it's IQ, because they're afraid that they will reveal things. Mm-hmm. So that becomes a somewhat serious issue. Who's going to anonymize and who's going to certify that they're clean enough?
Yeah, those are all good points. On the discussion
Can
of
I quickly react to that and just tie
Sure.
back to something that you said earlier, Mari? I do think the issue of whether data that is collected is considered private, sensitive or not is an issue that I think as a community we're not clear on. Right? I have attended meetings where you have lawyers and policy people who do this kind of stuff for a living, and they say, yeah, we don't know, right? And I think we really need to have that clarity in terms of, well, if you collect this kind of data, that's okay, but if you collect that kind of data, it's not okay, right? Because I do think anything in this space where we have ambiguity about that is really problematic from a researcher point of view.
Yeah, and I think that's actually a good reason. That means it's a good thing that the government is getting involved to target specific bands, because there will have to be solutions worked out for the data that is collected in those particular bands and in particular scenarios that the government wants to see. So again, not that I think that's going to be an easy process, but I think trying to define it for specific scenarios and specific test examples is going to be an easier task than trying to create blanket policies, which we're just never going to get very far. I see hands. I'm going to ask that you hold those for just a little while. We want to keep going with the discussion, and then I promise we will take questions at the end. I want to bridge into a little bit of the spectrum sharing discussion, because we, sort of talked about how well optimized the PAWR platforms are to support some of that experimentation. Is the thinking that we will be able to see some solutions actually potentially prototyped? There's all kinds of different spectrum sharing, right? There's time-based, there's frequency-based, there's, within geographic areas, all of these things. What is our thinking in terms of the types of scenarios that might be testable on the different platforms and might be useful for, the NTIA and government and folks investigating this to be aware of?
Yeah, so I can probably try to take a cut on this, and also kind of relates to some of the earlier question you had. I think in many ways, the different PAWR platform actually does capture different scenarios, right? From urban, deep urban to suburban to remote places. And yes, I think supporting BYOD is going to be super critical in terms of use cases and so on. That said, I think probably we do have some really decent measurement I think capability that's already available that should cover those bands. Some of those bands, for example, in the era of PAWR platform, we have the RF sensor from Keysight that's actually deployed at multiple locations, providing a wide space coverage for the whole sub 6 gigahertz band, including the 5.9 for the UAS and also the lower 3 gigahertz band. And like in ERA, there's actually 2 airports by those sites. Actually, those UAS, that's actually one specific use case we would be able to support. Actually, we're kind of actively exploring that. And also there's IoT for the TV white space band, like the spectrum sharing between IoT devices and broadband devices. That's actually what we have been looking at. For example, there's really low-end, low data rate IoT device versus the really like data-intensive imaging sensors on the vehicles. So those are some of the canonical use cases we are considering. I think at least in ERA, I'm pretty sure there are other use cases that are being kind of considered in the other platforms too.
Yeah, so from our perspective in terms of spectrum sharing, our focus at this point is mostly the SciNerds program that was mentioned before, and so we, roughly speaking, doing 2 sort of big things. They both relate to using powder to prototype radiodynamic zone functionality. And so there's 2 aspects to that. So the key one, I think that might be of interest to folks is we are developing what's sort of in the RDZ community is called the zone management system. And so it's sort of the spectrum intelligence that would operate an RDZ, and we're prototyping one of those. And in fact, we have a software framework we call Open ZMS that that will be open, or it is open as an open source. And the goal there is to create a framework that others can use, but also plug into, right? So it's a cloud native modular design, you know, all the right kind of buzzwords and technologies. So obviously we're using that within PAWR, and we're pretty close to having that as the spectral intelligence in our framework, as opposed to what we had before. And that includes, you know, we collaborated with folks from Georgia Tech on a digital spectrum twin, which is sort of the abstraction of that spectrum intelligence. So that's one big push. And then just to make this real from an end-to-end perspective, the other thing that we are doing is to explore different use cases associated with that. And so we have a couple of those that we're exploring on PAWR. You know, one was just GAA use among CBRS users, but then we're also looking at sharing with weather radar systems, which, you know, of course, very sensitive topic right there, and sharing with incumbents. And then there's one that's, I think, worth mentioning. It's just because it's a little bit more interesting. So we're collaborating with Kevin Gifford at Colorado on spectrum sharing with radio telescopes. No, for people who know PAWR, is we don't have a radio telescope in Salt Lake City, but the basic mechanism there was emulated in terms of the workflow on PAWR. And you know, we're in the process of integrating that with our OpenZMS system as an example. And we actually expect to do a field trial with them at the Hat Creek Radio Observatory in California in March. And so these are sort of all things in the space that we're exploring. And again, goal here is to be pretty open about this, have an open framework that others can adopt and make use of in other places, right? So we do, I think we will have to see how the whole RDZ or SciNet program plays out. At this point, I don't think we want to be the national radio dynamic zone, but I think we'd want to be a radio dynamic zone. And I think as that discussion in the community has evolved, there's sort of an acceptance that, yeah, maybe there will be a national radio dynamic zone somewhere, but there might be other radio dynamic zones, because they all kind of, and I think this kind of fits in with what Hongwei was saying, right? So they all have different focus areas. So yeah, that's sort of what we're targeting with our spectrum sharing activities.
You brought up a couple of really good points there. One being that the frameworks and the data that can be collected on PAWR can be used to inform work that gets done in other places. And I think that's a critical point, because as much as is available and is remotely accessible for doing experimentation on the platform itself, you can also take the intelligence from there and use it in other places to understand the level of intelligence that you're trying to glean. I also love the idea of some of these remote access tools. So again, not just the data, but that some of these tools can flow into other experimental workflows, and that there is, again, there's both sort of the facility and the resources and the assets that are there, but there's also the research work that's going on that should play into the continued experimentation and study that the government and others need to do.
And if I can add one thing just there, I think there's also one of the things that I think is pretty crucial in terms of the software architecture specifically, is to have that be done by professionals, right? I mean, we have to create these frameworks with people who know how to do this kind of stuff. We can't do this with graduate student efforts. I think graduate students can add into this, but you know, you have to have a sort of a sound framework to begin with. And again, that's sort of our approach here. And this is also why we want to make it open source, because we think this is a pretty good framework.
Yeah. So I just wanted to add to that, for instance, we are sort of trying to figure out how to create, as Kobus said, they don't have a telescope. We have some telescopes, but they're not radio telescopes, of course. But what we do have is interest from some of the federal agencies to sort of do experiments in New York City, because that's something that they cannot easily do anywhere else. And this especially goes towards testing with these various radars that they're using are doing. And in these discussions with the federal agencies, we actually came to a conclusion that it would be really nice to emulate, given that we have software-defined radios in the testbed, right? To emulate some of these devices and enable people to do experiments, even if the actual radars or actual waveforms are not available. And then there are sorts of interesting issues related to that. And just to add that we are also, as Kobus was suggesting, we are playing with nerds setups that are sort of based on some of the standards that people are talking about in terms of spectrum sharing, in particular the spectrum consumption model by IEEE, which sort of some of the industries sort of keenly looking into as a model for sharing.
And Mari, if I add, like the
Please.
digital twin concept, which sort of just really underlines and underscores both the things that Kobus and Ivan are talking about, right? That's going to become quite important, because that really easily helps you onboard what you may be seeing. So the ability to ingest that information and that data, whether it be IQ, RSRP, CQI, whatever it may be, and then trying to build these situational real-time spectrum maps to validate what may be happening in kind of a digital twin environment. And that's where you sort of have this closed loop feedback, where you are able to build, quickly experiment in an emulation environment. And that's what we've been doing on Colosseum, and obviously leveraging the PAWR platforms to ingest the data that they're collecting, validate it by building these real world scenarios, and then doing the coexistence, whether it be with the radar waveform, and that's obviously nobody's going to tell you what a DoD AWACS radar looks like, but you have the notion of what a pulse width of a nominal radar would be. So we're able to guesstimate that and do some initial early studies, and then also coexistence between CV2X, Wi-Fi, etc., which is continuing in that 7 gigahertz band. So that's all going to be important, but also we have to be very smart and agile with respect to where real world experimentation helps you, but then how can you actually use the emulation environment to provide credibility and validation of what's going to happen. And you need a cross-platform approach, whether it be from Cosmos to PAWR, the portability of the experimentation, and how that topology and architecture could be satisfied.
So I think it's important to emphasize a couple of the points that were just made, specifically around the digital twins. So much modeling that is done in the wireless radio networking space is done entirely based on, again, software models. The ability to add in this real world data from deployments to make these models far more emulating of the actual real world environment lets you then run some of those experiments and run some of those scenarios in a much more accurate way. Nothing is the same as the real world, but the level up that you get from actually employing real data from the spectrum environment, rather than the typical types of propagation models that we have leaned on for so long, is incredibly significant. And I think that's a huge value that the PAWR platforms can bring to the table here.
No, I'm gonna just quick comment there. Some of the external folks that have used our platform for spectrum monitoring, it turns out that Salt Lake City, and I'd like to take credit and say, oh, we saw this coming, but of course that's not true, right? It just turns out that this is a very interesting environment for that kind of thing, because we have city, we have mountains, we have valley, right? And so it they've actually been, the specific folks I'm thinking about have been using this location for measurements before we were here, and it just turns out to be a good location. But yeah, I think that sort of having the flexibility to explore measurements in realistic, well, and not to say I agree with Manu, there's room for emulation, but ultimately being able to see what these things look like in different real world environments is pretty critical, I think, for these studies.
I want to a couple of comments, maybe starting from the digital twin. I think there are two aspects of realism for digital twin. One is propagation models being realistic, and we have been having challenges. So for AERPAW, we have a digital twin of the exact environment where we are flying the drone. So we have the 3D mobility aspect. So the propagation at different UAV locations is critical. And we can use OpenStreetMaps. We have been doing some ray tracing simulations with that. But what's a big problem for us are the trees. So you can pull the data for buildings from online public sources, but for trees, it's not as easy. So we were looking at getting LiDAR scans and having a more realistic propagation environment. What we have seen is for some towers or connectivity with drones suddenly cuts after you move beyond the trees. But propagation is one aspect. The other aspect is, especially from a drone point of view, I think for digital twin, the radio is pretty much all the PAWR platforms. You can develop the radio software in the digital twin and then move it to testbed. But for AERPAW, we also have the mobility. So programming the real world software in the digital twin is very critical, both the drone and the radio, like the SDR software, and we couple those together, and your drone can decide how to fly based on what it's measuring. So you may have a spectrum sensing drone, so that based on what spectrum it's measuring or what propagation data, it may fly differently so that it improves spectrum sensing or communication accuracy. And I want to tie this also with the first discussion. So you were talking about metadata and SIGMF format. So it's very critical to add the critical metadata, and the obvious ones are time and location. So all your measurements should be timestamped and should have a location tag. But it's not only that, because what we have observed is for drones, if you fly with a different speed, your drone will have a different tilt, even the orientation of the drone, the antenna you use on the drone. So I think all of those should be included in the metadata. Otherwise, you may report some spectrum measurements without giving any of those, and someone else can do, and it may be completely different. Even for different speeds, different tilts, you will observe different measurements. I think it's a critical aspect to generalize all these. That's why we need more and more measurements with different speeds, different orientations. And one last aspect I want to comment is, again, that I want to emphasize the 3D spatiotemporal aspects with drones. So we have done, actually with helikites, we have done measurements in an urban environment the last 2 years. During a festival, we have been sweeping all the 6 gigahertz band, and we have noticed that in 2 of the bands there were 2 critical changes. One of them is the 3 gigahertz, 3.4 and 3.7. The other one is the 5 gigahertz, 5.7. And when we look at the spectrum measurements from the ground, they are visible, but it's very hardly visible. So the delta of spectrum usage is very little. But once you go up to like more than 100 meters, you see like a big difference between the usage from last year and this year, because you see all the transmission sources, all the base stations. Once you go above the buildings, I think the 3D aspect, monitoring the spectrum from as high as you can, is very critical. It will give you a much better picture.
So I want to quickly key off of that. I think, and the thing I want to key off of is the fact that spectrum use is changing very dramatically, and this is the thing that surprised us. And so I think, just back to what kind of data do we need to collect? I think we need to collect sort of longitudinal data, do long-term data collection to be able to see how these things change over time.
Right. Actually, just to add to this kind of more technical deep dive part, right? I think in terms of the data model, right? I think ultimately one of the basic goals is to understand the dynamics, or understand model the dynamics that involves at least the 3 dimensions, right? Like space, time, and spectra. And also be able to have actually multiple, basically, the part of the question will be, how can we collect ground truth data about this 3D space in different locations, different environment. I think that touches also like, how do you even synchronize multiple measurement point at a high granularity, right? Especially, I think as we hopefully look into the future of spectrum sharing, right? Some of the slice use could be dynamic, could be mobile, right? I think those will be some of the really interesting challenges for us to look into. Maybe kind of related point on this, and also the use case, I think, about the spectrum innovation, right? I think, even as part of the SciNerds or SII, Spectrum Innovation Initiative programs in general, I know we are focusing on some really low hanging fruit in a way, right? Like some of the most urgent, seems to be most urgent questions about, for example, passive, active, and so on. But I think there's also another use case that, a set of use cases that's going to be really important for connecting the remaining 4 billion people on the planet, right? Which is kind of how do you even allow spectrum to be potentially shared between different carriers? These are all active users, but they're carriers, right? So that's actually deserves a little bit more attention, I think, in general.
Thank you for that. I wanted to ask too, one of the questions, Kobus, when you were talking about some of the spectrum sharing systems that you all are developing, are those database driven at this point? Is that still where we are in terms of talking about spectrum sharing?
So no, not necessarily. So and I'll just pick the last one I talked about in terms of the work with Kevin Gifford. That's the exploration there is actually a very dynamic reactive kind of sharing where, you might use the spectrum and then whoever the spectrum provider or whoever the passive spectrum user might say, hey, you're interfering with me, right? And so it's much more reactive and real time. And even with our exploration with sharing with weather radar systems, there's a whole variety of things you can do there. I think the most practical one there, so these radar systems typically have a primary and a secondary band that they use, right? And so I think sort of a sweet spot there is to say, well, if you use the primary, we use the secondary, right? And so, and the other way around. Of course, you can use, you can do more intrusive things, but that seems to be an interesting sweet spot. And then that becomes, again, much more reactive, right? That's well, we have a monitoring system and the monitoring system says, oh, no, they just showed up in the primary. We better vacate it, right? Or whatever the case may be. So yeah, I think sort of all of the above is the way we're trying to think of it.
Do you think that some of these things are going to be, sorry, and then I'll let you jump in, Ivan, some of these things are going to be supported or tested first with a human in the loop and then evolve from there to more automated processes?
Yeah, we've had some. So the weather radar one is just really interesting. I mean, part of what John Chetwin and company wanted to explore in that program is to also push on the regulatory side, right? And so, okay, this is a nice example here. This is NOAA. How's NOAA gonna like us doing? So we're not close to actually sharing, right? And so we're going through this activity, engaging with them and saying, well, we kind of know what's going on here. We can detect it. What if? And then if we do transmit, what would be the limitations? And so, yeah, I think these are, there's going to be heavy process involved, and almost certainly there will be, we'll have to run our monitoring system for some period of time, where I don't know how that long is, and kind of prove that, yeah, we can do this accurately. We can actually detect it, and there's a fail-safe system here, and on and on and on, right? So I think all of those things will be quite important.
Ivan, did you want to jump in there? I think what you said is really important from the monitoring perspective, because I know that as the government is examining some of these things, there will be questions about power levels and usage across different spectrum bands, and the ability to prove that you can not only know what's happening, but also have a system for reacting to it in a particular amount of time. Again, being able to show the monitoring part first before you ever get to the point of even testing what could happen in that situation, I think is going to be a critical proof point to make people feel comfortable with the idea of testing some of these solutions.
And quick comment there, there's of course different types of monitoring, right? There's the monitoring that I just described, which is, well, that's going to be part of our spectrum sharing solution, as it were. But there's also sort of fail-safe monitoring, like what we're doing on our platform, where we have in-band monitoring, which is like, well, that's a completely separate system. If you got it wrong, we're just going to shut you down, right? And so I think those kinds of things will, especially as we're in this exploration phase, will be pretty critical to get people to that comfort level where, all right, well, I see you understand the space, you can detect it, you can shut things down if it goes wrong, right? So we need to get well beyond I think the current FCC, what is the term that they use? But you know, if you get a program experimental license, there's a number you can call to shut things down, right? I mean, I think it's just not sufficient, right? We need more sophisticated mechanism.
Yes, I was just going to jump in and sort of say that, and we were discussing before the long-term monitoring and that kind of stuff. Just to illustrate the actually much more serious problem where we had, and we still see it, and we don't know why, there is 1 minute a week interference coming from the George Washington Bridge at 24 gigahertz, and nobody can find out what that is.
1 minute a week?
Yes. And so the assumption is that it is some vehicle crossing the bridge or that's emitting something. And, you know, it's really funny. I mean, you suddenly realize that it's really, really hard to do proper monitoring at large sections of spectrum where you can detect these things. So anyway, I'm just saying it's
a phenomenal anecdote. That's incredible.
It's crazy. Well, and we are hunting it, but we can't, you know, it's impossible. There is no way. 1 minute a week is not enough time to do anything. So that's why I'm saying that also relates to human in the loop, right?
Yeah.
Some of these things are not, you know, humans, you know, emergency stop where somebody calls me on the phone is not the solution.
Yeah. Was there a last thing you wanted to mention there, Kobus?
There was this pizza delivery guy in New Jersey many years ago, and that sounds like one of those cases.
Yes, the GPS guy. Yes, absolutely.
Wild. Okay, so I want to wrap up the discussion before we go to questions and just ask each of the platforms to talk very, very briefly about, you know, we're about to embark on this massive, you know, study. It will actually be funded. There will be resources behind it to understand things going on in these spectrum bands and how we can solve problems with usage in spectrum bands. How should governments, industry, different organizations think about working with you and your teams to solve some of these problems? So how can they interface with you if they want to use the platforms for some of the study and experimentation work that's to come? And Kobus, why don't we start with you, and then we can go around the room.
I mean, I think we sort of set up to do that kind of thing. We have a recharge center. You know, we can generate quotes and bill people, and you know, so the mechanics are there. I think some of just thinking through the logistics. I think all of the cases we've supported, especially for non-academic use, they were all unique, right? And so I think it's going to be a discussion with everyone where you say, well, what is it that you want to do? Can we do that now, or can we do that with effort? Or what is it that you want to bring, and what is it you know, what is yours and what is ours, and how do we combine it, right? And I think that's sort of the tricky thing, that it's going to have to be a discussion in terms of needs and how we can support that. But I think once you get beyond that, and I think probably true for all the platforms here, you know, we're remotely accessible. We have sophisticated program experimental workflow. We have a reservation system. We have you know, isolation by group and by institution. So I think in terms of that piece of it, it's pretty well understood and well oiled at this point. But I think it's the nuances are going to be in, well, what exactly is it that you want to do, and how do we get there?
Great. Hongwei?
Yeah, so so I think you know, AERPAW is operational. We're going to actually have our webinar next month to actually share more details, but essentially it's ready for use. But in terms of, I think you think of the implementation of strategy, right? I think the mission of AERA is to help provide a platform for research and innovation on technology that hopefully can help connect the remaining 4 billion people on the planet, right? So that has actually deep implications about some of the technical questions in terms of which spectrum to focus. For example, some of the lower band, sub-7 gigahertz band, and also the NTN band, right, like 12, 13 gigahertz band. We also expect to be able to support NTN research pretty soon, as early as actually this year. So yeah, I'd love to work with folks who would be interested in this. We are just 1 email away, right? There's a e2@aerowireless.org. That's how we can get everything started.
And I will try to post some contact information as well at the bottom of this video. Ivan, do you want to jump in quickly?
Yeah, sure. So as you know, I would argue all of the above, meaning whatever Kobus and Hongwei already said. But you know, I want to also add that there is somewhat, I don't want to say conflict, but you know, the requirement that most of these experiments are multi-day, sort of long-term experiments, which then monopolize the testbed. So there has to be sort of some sort of planning for more serious studies that people really want to do. And we've seen that all over the place. Of course, it all depends on frequency bands. As long as people are not conflicting, then we can do multiple parallel experiments.
Devil's in the details. Ismail?
They mostly apply to AERPAW as well. One difference we have is we have drones and pilots. So most of the experiments we do are with both the fixed node on the ground, but there needs to be pilots flying the drones or the helikite. And we have licenses from FAA. We are working with FAA basically to fly at higher altitudes when needed. So for drones, it's 400 feet, helikite 500 feet without getting permission. And we can fly up to 1,000 feet for the helikite, for example, if you're interested to have data at much higher altitudes. And there are 2 main ways to interact with us. One is the contracts. If you want to have a new development that's substantial. If it's a standard experiment, we have testing services agreements, but it has to be using our canonical experiment model, which we have many sample experiments on our web portal. And we are also working on developing a service center, but that will take some time. We will actually we will move AERPAW operations to our Office of IT, who will operate AERPAW as a service center next year.
Great. And Manu?
Nothing new to add in terms of engagement models. All of the ones defined so far, they're all they're up and running already in terms of participation with federal agencies, government, etc. I guess on the Colosseum side, given that it's a digital twin emulation environment, the idea is that it's a little bit easier in terms of onboarding and a little bit more versatile. Because you have the ability to sort of tear apart the channel emulation environment to really set it to your own specifications. But I think what I want to really kind of emphasize here is that you are seeing a lot of diversity across these different platforms, and you have the ability to validate across platforms whichever technique optimization work you're doing. And we're already starting to see that. Some of the industry partners who are working with PAWR sort of trying to interact with us and saying, hey, doing that in the field is really, really, really hard. Can we sort of start testing this stuff in an emulation environment and then take those learnings back and then sort of move back and forth across these platforms? So I think that's really, I think, the unified PAWR here would be interesting in addition to the whole snowflake that each platform brings.
And that is the perfect wrap up. We will move into a Q&A session, but I do want to thank all of our participants here. And this has been a fantastic discussion of the PAWR platforms.